Imagine floating in a darkness so deep it feels tangible, a silence broken only by the faint hum of distant stars and the memory of a world left behind. This is where the Voyager spacecraft now travel, far beyond the sun's reach, in the silent sea of interstellar space, where sunlight is just a memory and the void stretches endlessly. Launched in 1977 at the height of the Cold War and the golden age of space exploration, Voyagers 1 and 2 were designed to seize a rare planetary alignment, an opportunity that comes only once every 176 years. Using gravity assists, they slingshotted past Jupiter and Saturn, gaining the speed needed to escape the sun's grasp and venture into the unknown, where cosmic rays and ancient starlight fill the void. These probes are our silent messengers, sampling the very fabric of our galaxy and sending whispers of data back to Earth across billions of miles. The solar wind no longer touches them. Instead, they drift through the interstellar wind in temperatures just above absolute zero, where even atoms move sluggishly and the sun is just another star. Yet their instruments persist, measuring magnetic fields, radiation, and particles in this unexplored frontier, providing the first direct data from beyond the solar bubble. Their journey began with breathtaking flybys of Jupiter and Saturn, revealing volcanic moons and intricate rings, but they were built to go further, to become interstellar ambassadors. Each carries the golden record, a time capsule of Earth's sounds and images, greetings in 55 languages, and music from across cultures, a message to any distant civilization that might one day find them. The Voyagers are a testament to human curiosity and ingenuity, built by teams who overcame the limits of 1970s technology, navigated the unknown, and pushed the boundaries of exploration. They are our eyes and ears in a place no human may ever reach, sending back data that rewrites our understanding of the cosmos. Their lonely voyage continues, carrying our hopes, our questions, and our story into the great unknown, an enduring symbol of what it means to reach for the stars. In the vast emptiness of space, a clear signal is everything, a fragile thread connecting us to the unknown. In late 2023, that thread frayed. Voyager 1's data stream, once a steady flow of information, suddenly turned to gibberish. The spacecraft was still alive, but its messages were indecipherable, a lifeline severed without warning. For the mission team, the silence was agonizing. Decades of work and discovery hung in the balance. The stakes were enormous. Voyager 1 is humanity's most distant emissary, and losing contact would mean the end of a scientific era. NASA's engineers launched a painstaking investigation. They traced the problem to a corrupted memory chip in the flight data subsystem, an ancient computer brain, battered by cosmic rays after 46 years in deep space. The chip stored critical code for packaging and transmitting science data. With part of its memory lost, Voyager could no longer speak our language. There was no way to physically repair the chip. The team faced a daunting challenge: rewrite the spacecraft's software from 15 billion miles away, with only fragments of memory left. They devised a workaround, slicing up the affected code, relocating it to healthy memory, and rewriting routines line by line, like salvaging chapters from a damaged book and reassembling the story in a new order. The troubleshooting process was grueling. Every command took nearly a day to reach Voyager and another day for a reply. Each step was fraught with risk. One wrong instruction could silence the probe forever. The team worked late into the night, double and triple checking every line of code, feeling the weight of history on their shoulders. In April 2024, after months of planning and coding, the fix was sent. The wait for a response was excruciating. Then at last, the first clear data in 5 months arrived. Relief and joy swept through mission control. Voyager's voice had returned from the void. The spacecraft's signal, once lost to static, was back, proof that ingenuity and perseverance could overcome even the cold silence of interstellar space. By June, all 4 science instruments were once again sending precious data from beyond the solar system, their signals a testament to human determination. The crisis was averted, not by luck, but by relentless problem-solving and teamwork. Voyager's story, our story, continued, echoing across the stars. Just as Voyager 1's precious data began streaming back to Earth, a new crisis loomed. Its backup thrusters, responsible for keeping the antenna locked on Earth, were failing after decades of harsh space radiation and cold. These thrusters, tiny rocket engines using hydrazine fuel, had been designed in the 1970s for short, precise bursts. Now, after years of inactivity, their reliability was uncertain. The engineering team faced a daunting choice: attempt to revive the original roll thrusters, dormant for over 20 years, or risk losing contact forever. Warming the frozen thrusters would drain Voyager's already dwindling power reserves, and a misstep could trigger a system failure. In early 2025, after careful simulations and sleepless nights, the team sent the command, a digital lifeline that would take nearly a day to reach Voyager, now billions of miles away. For almost 2 days, engineers waited in tense anticipation, knowing that any error could end the mission. The silence was heavy, broken only by the ticking of clocks and the hum of computers. Then, at last, a signal. The heaters had worked, and the thrusters fired as intended. Relief swept through the control room. Cheers, tears, and high fives marked the moment. Voyager 1's orientation was restored, its antenna once again locked on Earth, allowing the flow of data to continue. This daring revival was more than a technical fix. It was a testament to the ingenuity and perseverance of the Voyager team, and a historic moment in space exploration, proving that even dormant systems from a bygone era could be brought back to life. Against all odds, Voyager pressed on, its journey a tribute to human curiosity and resilience. The Voyager's power is fading, their radioisotope thermoelectric generators, RTGs, growing weaker with every passing year. Each year, the RTGs lose about 4 watts, forcing NASA engineers to make difficult decisions about which instruments to keep alive. To conserve precious energy, instruments are being shut down one by one, a slow, deliberate farewell to decades of discovery. In early 2025, Voyager 1's cosmic ray subsystem was turned off, ending its ability to study high-energy particles from distant galaxies. Soon after, Voyager 2's low-energy charged particle instrument followed, closing a chapter on our understanding of the solar wind's edge. Each shutdown marks the end of an era for a field of study. Cosmic rays, plasma waves, magnetic fields, each loss felt deeply by the scientists who devoted their lives to these signals. By 2026, nearly all science instruments will have gone dark, their voices silenced one after another. Only the most essential systems, communications, attitude control, will remain, running on the last trickle of power. Even after the last scientific instrument falls silent, the Voyagers will continue to send engineering data, health and status reports across the void. These faint signals, growing weaker each year, will be the last heartbeat from our farthest explorers. By the early 2030s, even these engineering whispers will fade as the power finally runs out. The silence will be profound, a testament to the end of humanity's longest reach. Yet, the Voyager's journey will continue, drifting through the stars, carrying our message long after we can no longer listen. As the Voyager's signals fade, we approach the end of their active mission, but their legacy is far from over. Soon, only a faint carrier tone will remain until that too disappears. Yet the data they sent back transformed our understanding of the solar system. When silence comes, humanity will lose its most distant connection to the cosmos. But the impact of Voyager lives on in classrooms, museums, and the dreams of future explorers. The Voyager's legacy is not just in their discoveries, but in how they expanded our view of the universe. They revealed active volcanoes on Io, the complexity of Saturn's rings, and the deep blue mysteries of Neptune. They unveiled the wonders of the outer planets, capturing sights never before seen by human eyes, and then ventured into interstellar space, becoming our first messengers to the stars. Their final signals are the last words from humanity's greatest voyage. Scientists speak of Voyager with awe, calling it a triumph of curiosity and collaboration. The story of Voyager is a story of human ingenuity, perseverance, and hope. Engineers and visionaries poured their hearts into these spacecraft, inspiring generations to look up and wonder. Long after their voices fade, they will drift among the stars, carrying the golden record, a message of music, greetings, and hope from Earth, across the galaxy. The idea that someone, somewhere might one day find it, continues to inspire wonder. Their journey is a permanent reminder that we dared to explore, and for a while, we called home. The Voyagers paved the way for future missions, igniting a passion for discovery that will guide humanity's next steps into the unknown. As we look up at the stars, we remember Voyager, not just as a spacecraft, but as a symbol of our shared quest to reach beyond and to understand our place in the universe. As the Voyagers journey ever deeper into the cosmic dark, they carry with them a unique treasure, the Golden Record. Conceived by a team led by astronomer Carl Sagan, this 12-inch gold-plated copper disc is more than just a time capsule. It's a greeting, a portrait of Earth, and a message in a bottle cast into the vast ocean of space. The creation of the golden record was a race against time. In just a few months, scientists, artists, and engineers worked together to select the sounds, images, and music that would represent all of humanity. Their choices were both practical and poetic. Greetings in 55 languages, the sound of a heartbeat, a kiss, the laughter of a child. There are images of people from around the world, scientific diagrams, and the very first musical notes ever recorded. Perhaps most moving of all is the music, a 90-minute journey spanning cultures and centuries. From Bach and Beethoven to traditional songs from China, Peru, and Senegal, the golden record weaves together the diversity and beauty of human expression. There's even a recording of the brainwaves of Anne Druyan, Sagan's collaborator and future wife, capturing her thoughts of love and hope for the universe. The golden record was designed not just for possible extraterrestrial listeners, but as a reflection for ourselves. Engraved on its cover are instructions for playing it, mathematical symbols, and a pulsar map pointing the way to our sun, an invitation to any finder, wherever and whenever they might be. Today, the golden record drifts quietly through interstellar space, a silent ambassador from Earth. Its message is simple yet profound. We were here, and we wish to be known. Whether or not it is ever discovered, the record endures as a testament to our curiosity, our creativity, and our longing to connect across the stars. In sending the golden record, humanity reached out, not just to the unknown, but to the future, and to the infinite possibilities that await. As the Voyagers left Earth behind, their first encounters transformed our understanding of the outer planets forever. At Jupiter, Voyager 1 and 2 revealed a world of turbulence and beauty. They captured the iconic image of the Great Red Spot, a centuries-old storm larger than Earth, and discovered Jupiter's faint rings, invisible from our home planet. Most astonishing were the volcanic eruptions on Io, the first active volcanoes found beyond Earth, reshaping our ideas about where life might exist. Next, Saturn awaited. The Voyagers sent back breathtaking images of its dazzling rings, uncovering intricate details, braided strands, spokes, and mysterious gaps. They found new moons and witnessed the enigmatic hexagon at Saturn's North Pole, a geometric wonder swirling in the planet's atmosphere. On Titan, Saturn's largest moon, the spacecraft peered through thick clouds and detected a dense, nitrogen-rich atmosphere, hinting at the complex chemistry that could one day reveal the origins of life. Voyager 2 alone pressed onward, becoming the first and so far only spacecraft to visit Uranus and Neptune. At Uranus, it discovered 10 new moons and the planet's faint rings, while revealing a tipped, blue-green world with a magnetic field unlike any other. Neptune, the final stop, surprised scientists with its deep blue hue and supersonic winds, the fastest in the solar system. Voyager 2 discovered the Great Dark Spot, a massive storm, and captured haunting images of geysers erupting from Triton, Neptune's largest moon, hinting at energy and activity in the coldest reaches of the solar system. These encounters didn't just rewrite textbooks, they sparked new questions and inspired generations of scientists. The images and data sent back by the Voyagers revealed worlds more dynamic and diverse than anyone had imagined, forever changing our place in the cosmos. Each discovery was a reminder, the universe is full of wonder, waiting to be unveiled by those who dare to explore. Behind every breathtaking image and groundbreaking discovery, the Voyager twins are engineering masterpieces, designed not just to explore, but to endure. In the harsh emptiness beyond the sun's warmth, power is scarce. Each Voyager was equipped with 3 radioisotope thermoelectric generators, RTGs, turning the heat from decaying plutonium into electricity. These silent power plants have allowed the spacecraft to operate for over 40 years, their energy output gradually fading but never failing. Redundancy is Voyager's silent guardian. Nearly every critical system, computers, transmitters, attitude controls, has a backup, ready to take over in case of failure. This foresight meant that when a part wore out or cosmic rays struck, the mission could continue, often with ingenious workarounds sent from Earth across billions of kilometers. Voyager's antennas, each a 3.7-meter dish, have faithfully aimed their signals home, guided by gyroscopes and thrusters so precise they can adjust orientation by fractions of a degree. Even as their power dwindles, careful mission planning allows engineers to prioritize which instruments remain alive, squeezing every bit of science from the remaining energy. Perhaps most astonishing of all is the way Voyager's team planned for the unknown. Software updates, reprogramming from afar, and creative problem-solving have kept these explorers alive far beyond their original lifespans. Voyager's survival is not just a triumph of hardware, but of human ingenuity, proof that with vision, preparation, and a bit of luck, our reach can extend across the stars. As Voyager sails ever deeper into the cosmic ocean, its story continues to ripple through the world of science and beyond. The legacy of Voyager is not just etched in data tapes and distant signals, it thrives in every mission that dares to reach further. Its success inspired the New Horizons probe to Pluto, the Cassini mission to Saturn, and the upcoming Europa Clipper, each standing on Voyager's shoulders to push the limits of exploration. Voyager's journey, bold, uncertain, and relentless, has shaped the dreams of a new generation of planetary scientists, engineers, and stargazers. Its discoveries of possible ocean worlds, complex magnetic fields, and the dynamic dance of moons have sharpened our search for life elsewhere. Are there other places hidden under icy shells or in distant star systems where life might take hold? Voyager's findings urge us to ask and to seek, but perhaps Voyager's greatest gift is the spark it ignited, a quest that transcends technology and science. Today, missions like Breakthrough Starshot and the search for exoplanets carry forward Voyager's spirit, envisioning journeys to other stars and the possibility of messages yet to be sent into the void. With every new mission, every new question, Voyager reminds us that the desire to explore is woven into our very nature. As we look to the future, Voyager's trailblazing path lights the way, a testament to curiosity, to courage, and to the unending human urge to discover what lies beyond the next horizon.